Okay, so the first thing I want you guys to do is if we look at this question right here, we're not going to follow the directions. I'm going to ask you lots of things that pertain to our exam. So first of all, what form is this quadratic in? Very good. Okay, so this is in vertex form. And in vertex form, we should be able to find the vertex. So can somebody tell me, based on this equation, where do you see the vertex at? Yes. It's at positive 2, comma 4. And if you don't remember that little rule that it's opposite here, so positive 2 when it says minus 2 and plus 4, here's what I want you to think about. And you don't have to draw this in, but isn't y equals x squared kind of our parent function? And x squared goes through the origin for the vertex. You don't have to draw this. So if x squared is our parent function and the vertex is at 0, 0, remember in Mathia when we talked about translating a function, what does the minus 2 inside the function shift it? 2 to the right. And what does the plus 4 on the outside? Up 4. So you may want to think about it in terms of translation, that we are really translating 2 units to the right and up 4. So I know some students get really good at spotting those translation factors, and that might be easier. Okay, so that encompasses some good questions for exam review. Is this quadratic going to open up or down? Good, got that down real well. This is going to open down because of that negative 3. So we know that it's looking something like this, but we don't know much more. Okay, looking at this form of the equation, can we find the y-intercept? I heard yes and I heard no. Is our y-intercept the plus 4? No, it can't be. We do not know the y-intercept just by looking at this because it's not in standard form. Okay, but over here, we're going to review how to find that. If we want to find where this line hits the y-axis, any point on the y-axis has an x value of what? 0. So here's what we're going to do. We are going to substitute into our equation 0 wherever we see x. So our equation up here was y equals negative 3 times the quantity of x minus 2 squared plus 4. So we're just substituting that in. And now let's calculate using order of operations. So 0 minus 2 is what? Negative 2. What's negative 2 squared? 4. What's 4 times negative 3? Negative 12. And negative 12 plus 4? Negative 8. Okay. All right, the next thing, where is the axis of symmetry? Not at 2.
0.
At x equals 2. So remember, axis of symmetry is a equation of a vertical line, x equals 2. And here's an exam question. I will give you an axis of symmetry, and I'll give you one point that's on the graph, and you have to find the other point that's symmetrical to the one given. So can you find the symmetric point of 0, negative 8? Good. So what symmetric means is you have to figure out how far this point is to the left of the axis of symmetry and go the same amount to the right. And that would be 4, negative 8. Good on that? All right, so all of that is review. And the goal is we now want to calculate what the zeros are. And calculating the zeros, another name for that, is we are going to solve the quadratic. And that's been our goal this whole chapter. Okay, you should be making notes here. Okay. What is the first step for solving a quadratic? Yay, good job. You have to set it equal to 0. So we are going to write our equation like this. Set it equal to 0. When you set it equal to 0, we're saying y is 0, and we're finding the x values when y is 0. So that's going to be some points that are sitting right here on the x-axis. Okay, looking at this form of this equation, what method do you think we're going to do to solve this? Good job, Sophia. Square root method. So eventually we want to take the square root of both sides, but we have to do some things first. Caitlin, what do you think we do first? Good job. I'm going to subtract 4. Okay, Brady, what do you think we do next? No, we don't need to distribute. There's an easier thing to do. Sam?
Would it be to divide both sides by -3?
Good. We want to divide both sides by -3 so that the term that is squared is isolated. I'm going to say that again. The term that is being squared is all by itself with no coefficients, nothing added or subtracted. Gigi, you with me? Getting this? Okay, what would be the next step? Oh, wait a minute. Why did I change this to this? Because a negative divided by negative is positive. Okay, Gigi, what do we do next?
You square the x to 2.
Nope, you don't have to do that.
Add 2.
No? Very good. We want to cancel out squaring, so we're going to take the square root of both sides. When you take the square root of both sides, on the left here, what are you going to be left with? Good job. Plus or minus, and we can leave it like this. What happens on the right? Very good. The square root and the square cancel out, and we're left with just x minus 2. You have this down? Okay. What do you do next, Noah? Very good. So x is going to equal the square root of 4/3 plus 2. And negative square root of 4/3 plus 2.
You have to make it a.
Okay, so these down here are the exact solutions. So if the exam asks you for the exact solutions, you will leave it like this. But for us to draw a graph, does anybody know where the square root of 4/3 plus 2 is on a graph? No, I have no idea right now. I could guess where it is, but I don't know where that is. So then we grab our calculators. So we turn this on, and we're going to do square root, and then press alpha and the key right next to it to build this fraction. So you get square root of 4/3, but then you have to use the right arrow to get outside of that square root sign. So make sure your calculator is showing that the plus 2 is not underneath that square root. And there's one of the approximations. Okay, so I'm going to go down here and say that this is approximately equal to 3.15. Okay, now I like shortcuts, so I don't want to have to retype this again. So press second and the enter key. And move your left arrow all the way back until your cursor is blinking right in front or right by there. You with me? Okay, now we want to insert a negative sign. If you just type negative, it's going to go on top of the square root and that's going to disappear. So above the delete key, you see where that is? Top row.
Going to the left.
You can't go any further. I'm as far as I am to the left.
Mine let me go to the left.
Okay. Well, I'm going to press second and the delete key, and it changes the cursor to insert mode. And now I can hit the negative sign, and it will insert the negative sign. And we get this. So there's our two answers. Remember, our axis of symmetry was at 2, so these two numbers are equally spaced on both sides of the axis of symmetry. So I'm going to go up here, a little bit past 3, a little below 1, and we now get our quadratic.